Hello, this is another episode of Herbal History. In this episode, we'll cover the miracle fruit, also known as Sinspalum dulcificum. This fruit tree species is a poorly researched and utilized resource. In this episode, we'll cover the plant's biology, its ethnobotany, and possible pharmaceutical uses and research paths. We'll start with the biology and natural history of the species. The miracle fruit comes from the family Sapotaceae, a large plant family with between 30 and 40 different genera, of which the knowledge of these species are obscure to this day. The genus Sisipetulum is confined to tropical Africa and has 30 species within this genus. The miracle fruit is of this genus. The miracle fruit is the most widely distributed of these species. This tree manifests mostly as a shrub reaching 4 meters tall. The trees of these plants have leaves similar to that of avocados, only smaller and much more tightly packed together. These trees bear pink to red fruit that are oblong in nature, resembling a mixture of a cherry and a plum. Its natural range and center of origin is likely Western tropical Africa in a country complex of Ghana, Togo, Benin, and Nigeria. The flowers of this species are autogamous, meaning they're hermaphrodite in nature, and they also self-pollinate, although cross-pollination is also possible. There's scarce information, however, on what pollinators pollinate this plant. When it comes to propagating this plant, the plants can be propagated by a seed, with a success rate of 80.5%, and seedlings grow better and faster than cuttings. In tissue culture, a researcher found that by adding IBA in high concentrations, rooting can be facilitated within these artificial circumstances. So the current mechanisms of production for miracle fruit include seeds, cuttings, and tissue culture. This plant undergoes 2 growth phases. The juvenile period, which lasts for its first 4 years, is purely vegetative and it grows very slowly. After it reaches 4 years old, it grows and matures faster in its second stage. At this point, the species will flower year-round and produce fruits and flowers throughout the year. Now on to its ethnobotany and uses. The miracle fruit was found to contain anthocyanin, or purpley red colorations, and flavanol pigments. These pigments have potential to be used as natural food coloring. Most of these pigments are red in nature. The miracle fruit's sweetening property, which we'll discuss further in the use section, has been used to make sour palm wine sweet. It has also been used as an appetite suppressant, historically speaking. In India, the leaves are used as an ingredient in bread making, or cooked as a vegetable. It has also been used by people in the Philippines as a means of improving the taste capabilities of chemotherapy patients. It has also been used in parties to alter the flavor of different fruit as a party trick, also in the Philippines. In Indian folklore, a poultice made from this plant's leaves is applied to the stomach to relieve cramps. Now on to the research potential of the miracle fruit. Now on to the possible research opportunities and medical uses. The main use of this plant is through the use of miraculin, a glycoprotein found in the fruit that alters the behavior of the taste bud. This chemical makes everything sour taste sweet, basically. This is temporary, however, so there's little danger of permanent taste alteration. This is one of the anti-diabetic plants utilized in the essay in my university course. Due to the ability of this plant to alter the taste buds' behavior with sour things to make them taste sweeter, this plant could be used to reduce caloric intake in diabetic patients. For type 2 diabetes, this will help maintain a healthy blood sugar level, but the level of miraculin differs from plant to plant in the fruit. and as such, for commercial production of myrcalin, it would be necessary to breed new variety and propagate existing varieties that have high levels of myrcalin, which brings us to the next types of research avenues that are being studied. The first being the improvement of asexual propagation. Vegetative reproduction fixes pre-existing traits, including the active ingredient used to alter taste buds. It also reduces the juvenile period length as well. Unfortunately, it's still difficult to propagate miracle fruit with cuttings, although it's successful when aided with IBA. Further research on cutting length and diameter in association with IBA root hormone will be required to further propagate ideal samples of the miracle fruit plant. Finally, there should be an improved knowledge of the species in general and the amount of variation that exists, both in wild specimens and cultivated specimens, as that knowledge is very limited. A good conservation methodology requires knowing to a certain degree the total populations and the variations within these populations. It would also be useful for further plant breeding as well. Perhaps in some future date we will have isolated many different land races and wild populations and be able to categorize them for both breeding work and conservation. Once we do so, you'll have a sustainable source of breeding material for the production of miracle fruit extract and a possible new means for controlling blood sugar. Well, that about covers everything. See you in the next one.